Shake Table Lab by Bea and Ellen Carter. Before we began building, Ellen and I made a building sketch. We made it so the width would be 16 centimeters, each story would be 18 centimeters, and the overall height would be 36 centimeters. Ellen and I also designed it so that the walls would have X's on them, so that there would be more support and so it would be harder for the building to collapse. Ellen and I started building our structure by building the frame for our building. We built the base, which was 4 sticks arranged to form a square. Then we decided to build the corners of our structure. To do this, we put straws into other straws in order to make an extra long straw. After making these extra long straws, we taped them down to form the corners of our structure. Ellen and I are finishing with the frame by adding straws to the top to form a square. We have added more tape to strengthen the weakened parts on our frame. At the top, we finished off the frame by sticking straws into straws that are standing up. This formed a square shape and is where the floor of the second story will be. We are adding cross supports on the walls of our structure. Ellen and I have already finished attaching another square in the middle of our structure. These squares are where the floors will be. The X's on the walls that we are starting to build make it harder for the structure to collapse. Ellen and I have now finished adding all of our cross supports. Now we have added cross supports on all of the walls and on the places where the floor will be. We have started to add more supports in the center of the X's for even more support. Ellen and I made this building construction sketch of our finished structure. We took a picture of our structure and made sure to clearly label the width of the base, the height of the first story, the width of the second story, the height of the second story, the width of the third story, the height of the third story, and the overall height of our structure. After we finished building, we had to do a static test. We put 4 250-gram weights on our structure. The very start of testing our building was this. There was no difference in our tower with the weights. To strengthen our structure, Ellen and I put 2 straws in the center of our building. We did this twice on the first and second floor. Putting these straws in the center of our tower helped strengthen our structure because they gave more support in the center of the structure where there were no supports. The strongest parts on our structure were the corners. Many of our beams were attached to the corners, which made the beams stronger and the corners stronger. It is important to have strong corners because the frame of the structure includes the corners, and it is important to have a strong frame. The weakest parts of Ellen and my structure were the floors. What makes the floors the weakest parts of our structure is that they are made out of paper. Although we have straws that form an X under the floor, it is still weak in the areas where the straws don't reach. For our structure, Ellen and I used a considerable amount of tape. We thought that we could reinforce our structure with lots of tape. Ellen and I used especially a lot of tape in the corners and on the floors. Tape was a key supply, especially for Ellen and I. In addition to the straws and tape, we were also given paper to use for our structures. Ellen and I used paper for our floors, our roof, and to make our flag. Having an extra supply such as paper was helpful because we could use it for our roof, floors, and flag. In order to see how strong our tower was, we put it on the shake table. We began testing the strength of our tower with 4 sandbags. After each shake, the amount of sandbags would be increased by 2.
It's gonna break.
Our tower was able to hold 18 sandbags but collapsed at 20.
Oh my god! No way!
This is an XYZ graph that detected the motion on our structure as it was shaking. The green line is the x-axis, and this represented the side-to-side motions during the earthquake. The orange line is the y-axis, and this represented the forward and backward motions. Lastly, the blue line is the z-axis, which represented the up and down motions on our structure. These are Ellen's thoughts and reflections on our tower.
My name is Ellen Carter, and today I'll be talking to you about our shake table structure. Our building held 18 sandbags. Our building failed towards the middle of our tower. I think it collapsed because our floor wasn't as strong as it appeared to be. I think we could have added more straws to our second floor to add more support for the floor. I learned that it is a very complicated process to earthquake-proof a structure, and if something went wrong, people's lives would be in danger. Therefore, you must add as much support as you can. I enjoyed building the third story of our structure because we were able to be creative and do whatever we wanted.
These are Bea's thoughts and reflections on our tower.
My name is Beatrice Prey, and today I'll be talking to you about our shake table structure. Our structure held 18 sandbags but collapsed at 20. Our building failed in the middle because we didn't have enough supports. To make our tower stronger, we would have added more supports in the center near our floor. I learned that it's very hard to make a stable and safe structure with a limited amount of resources. What I enjoyed about the lab and building was getting to test out our strategies and seeing if they worked.